Welcome, Mr. Patrick Schumacher.
Good to be here. Very impressive video, by the way. It's a great company, and it's very important for designers to have the backing of very sophisticated industrial firms. And thanks to Javier and the communications team for inviting me to be president of this jury. The contributions were very high level, and I'm very proud to be participating. So I will talk about a new development, recent development in architecture and design. It's a new style I've proposed to call Tectonism. But don't worry, parametricism isn't over. It's a subsidiary style, the latest stage of parametricism, and applies to architecture, as I said, as well as industrial design, interior design, etc. And it is tied in with our upgrading of technological means in developing designs and interfacing with new engineering logics, fabrication logics, environmental logics, and how they influence and become drivers for a new stylistic endeavor. So I will, spend a few minutes on this. So this is what this new world looks like, and you can see it's very rich, very diverse in terms of textures, morphologies, even colors, materials, detail reticulations, etc. And it has some precursors you can see in the images. Sagrada Familia is one of them, the great Gaudi, who was not inventing form but finding form according to the logics of structure and physics, and Friotto as well. And the rest is all contemporary figures. We are within that, but there's quite a few others. I want to name, for instance, Achim Menges and Mark Fons, among many others. And so this is how I want to define Tectonism, that it is a stylistic heightening of engineering and fabrication-based form finding and optimization processes. Stylistic heightening because, after all, as designers, we are very much interested in the expression, and design is always also communication, so it is not only an aspect for us of technical optimization, but the morphologies which are coming out of this are very rich and become a beautiful repertoire of articulation. So, in terms of my theory of styles, I'm distinguishing epochal styles, and the last big transition was from modernism to what I now call parametricism, which has to do with the introduction of computational technologies, but also the changes in society which are driven by the new convergence of computation and telecommunication, which has dynamized society, which required a new style, I would believe. So, but you can see that here modern has a series of subsidiary styles. So 60, 70 years of modernism wasn't a monolithic development, but had a series of steps. And I think in parametricism, I started about 25 years ago, we have already seen a number of subsidiary styles, which I will explain. So parametricism, I think, emerged in the mid to late 90s, and 10 years later, I was reflecting on the fact that we had a new stable paradigm for over 10 years, and I coined the phrase parametricism. And actually, parametricism also encompasses urban design and a new order of the city, as well as architecture, interiors, and product design. So this is just an overview. That's the work of Zadid architects across the various scales, all the way from urbanism through architecture to products. And there's a kind of precursor. Zadid's first sketches from the 80s show already this interest in a new level of complexity and dynamism in her repertoire. And in terms of the first expression, as it were, of parametricism, I term it in retrospect foldism. It starts with the idea that one, instead of building up complexity by adding up pieces or layering pieces like in deconstructivism, one can take a single surface and differentiate this. And it is a very, very adaptive and fluid set of systems which pick up contextual features, internal requirements, and get something going which has both coherence and intensive differentiation. So just a few of those projects which worked with this kind of idea of a differentiated single surface. It's not only Zardid Architects, there's FOA. It also moves from buildings to furnishings. Some of our works, student work, this was corporate interiors, urbanism again, and interiors. You can see here that the idea here is that you have a continuous variation where situations morph and modulate from one into the other seamlessly. So it is standing against a clear separation of domains and against the cellularization of space into discrete and separate domains. And just going to move you through some of those interiors. Now, there's also a bathroom from us in part of a hotel room, actually in Madrid. This is a continuous Corian surface material, which is a lot happens in the bathroom, so use this for the whole room. And you can see here that the elements are not plugged onto each other, but one surface is modulated. This is a door where the handle is kind of evolving out of the door surface, or a table which I've designed. But we also find this kind of philosophy in car design. Instead of plugging on a kind of headlight, it's kind of modulated into the surface. And this also goes into product design and fashion design, jewelry design, if you like. So, and the idea of parametricism and this kind of surfaces is that there could be a system or genotype which can then adapt itself to different conditions and be varied across. And again, in an interior where all the different features and aspects are made out of one continuous surface. I'll just click through that rather quickly, some of our works on various scales. And, you know, a staircase is just another rippling of a surface which becomes wall, ceiling, the lighting part of the same formalism. And if you do this, you declutter the space. You have a lot of richness, diversity, but the essential features of the space are easy to grasp because they're not cluttered up by adding lots of pieces together. And you can also switch atmosphere, and the same principles move from gypsum into timber. And again, the surface delivers the various features and aspects which need to be distinguished and delivered. More recent attempt, the way 3 different institutions of a cultural complex, a museum, an opera house, and a multipurpose house. It's all about embedding this into a landscape and becoming, again, a continuous surface condition. This is just about to finish on site right now. So as you can see, foldism continues, even though we are in a different stage. These projects take many years to evolve. So what is happening now and finishing on site is not necessarily the latest in our design thinking. So again, this also goes for interior spaces. The continuity of space, we're also applying this to towers now. Instead of separating floor by floor and then cellularizing everything, it's all about a continuous experience you can navigate. So I'm very interested in towers which are opened up through interior atriums. So the next stage, very similar in a way, is this idea of blobism on blobs, volumes which fuse, and again, it's nearly another version of that first stage, where you move smoothly from one zone to another, and they're kind of partially articulated. And again, there's a whole world of elements which comes out of that. And you see, it's quite striking set against all prior architecture. It sticks out, but it also delivers a new level of complexity, 3-dimensionality. I describe it as maintaining legibility in the face of complexity. The fused 3-dimensionality of this is remarkable. So, and again, this my new passion for mega atriums. So the interior continuously differentiated interior world where everything is inter-aware, intervisible, and variation instead of separation is the game. And this is a project which actually we're working on now, trying to bring on site. Swarmism is something very similar also, but it applies to urbanism and the idea of having discrete elements, but so many that they're no longer parts, but particles which associate in different ways and can differentiate an urban scene. So you don't need to have literally contiguity, you can have swarms of elements which deliver variation and differentiation. And again, I'm interested that this operates on an urban scale as well as on an interior and product scale even. Tectonism. So what's new? The difference is, you can see it immediately, there is much more grain texture variety. It's not just the different morphologies and forms, they actually become disciplines. It's not just the NURB surfaces, but you can see there's creases, pleats, much more distinct identities, and there's various different materialities, and the material matters and becomes a driver of the both overall form and the articulation. So we now show structure much more rather than kind of wrapping everything into continuous surfaces. So the tectonics has always been this principle of heightening technical issues, whether it's these joint lines, which the form of the arc, the way the stones are set, as well as then the expression of the strong joints and the rustication, shows that everything which is initially a structural material logic becomes heightened into a stylistic expression and an ornamental understanding. So ornament and structure are not separate, they're dimensions of architecture which fold on top of each other. So we're starting with performance-based design via engineering logics, and we're looking at structural, environmental, and fabrication rationalities. And then these are heightened into stylistic repertoires, and they characterize the space, giving a strong identity expression to particular space. And this has been throughout history. So you can see here that the morphologies are have structural logics, but they also become expressive and are treated as such. So the kind of coincidence of purposes. And there's always multiple options. But they all share a very high structural performance, what you can do with stone. And so we've learned from this, we picked that up to give more grain structure, but then run with this in terms of variation, not the repetition of a particular bay, but also letting the exterior participate in this and moving from compression only to tension as well, variation. And these are studies I did with students in AA. And then we moved on to what we're doing in the office, various shell formations. And you can see here that variation is the game. And again, going back to Gaudi, and learning from working with materials to find these forms, to find these morphologies, with working with models, and then translating that gradually into the digital medium to have more versatility. So this is models from the Architectural Association, the Design Research Lab. And that's part of a design research to develop these range of forms. What comes to light here is the diversity of forms, textures, materialities, which is an enrichment far beyond what any traditional architecture had at its disposal. Also far more what modernism had at its disposal, and far more what parametricism had at its disposal. But there are these precursors like Feuerto. And you can see that there's a very particular identity which all tensile structures share. So you can make an enormous amount of variation, but they then maintain an identity across all these variations, which makes it recognizable what belongs together. So that's what I'm interested in. It's non-arbitrary rigor to a design variation. And if you look at stone shells, again, we have a researcher like Philip Block we're working with, and he can unleash them from the traditional insistence on point and bilateral symmetries to make a very, very free form, make them super thin, and then you can see that the tessellations also are coherent with the overall form, and you get a very, very versatile new repertoire for architects. What is significant here is it's super efficient, but also very beautiful and recognizable. It gives identity, something which we need in the built environment. And there's also an interest in the different textures which come out at you see the top edge, these kind of facets show off this kind of idea that you just work with what comes out of a construction process and make that the ornament is very interesting to me. And again, there is very sophisticated ways of creating these. So we worked with him and developed these compression-only stone walls, and learning again from history, because you find a lot of intelligence there, even though there wasn't a science behind this, recuperate this and make it a new engineering-based stylistic venture for us. Now, I want to show some of these pavilions. This is from Stuttgart, Achimenges, timber shells. There's also environmental reactiveness to moisture, these open and close, depending on moisture. And there's different versions of this, and I think there's a beauty in this variation, which is much more than just the parametric form. It has this porosity, it has morphologies that have to do with the active bending of timber here. And this variety is very important to us. And to work directly with engineering software, for instance, to analyze the stress distribution, optimize and generate ribbing patterns, which we then recognize as an ornamental layer, give character and identity, but they also will tell you where's the column, where's an opening, so they guide and orient the user through a space, rather than having a generic grid, which is kind of untelling. So I talk about information-rich environments. So high-performance environments become information-rich environments. So we worked with this and took kind of Candela shell and translated this into a optimized grid shell with these kind of differentiated shell lines, and you get something very striking and strong, which again emphasize where openings and support points are. Tensile structures, of course, are always very typical forms, so we like them. They give identity and character. And the thing is that the constraint, we give over some of the form and shape making to an optimization process. But since there are so many we could choose from and we can set the boundary conditions, we still feel have many degrees of freedom to and be creative and empowered with our creativity with these. So this is something I want to show on a smaller scale. The way we develop, we take the chair, the basic outline. The first thing is optimizing the shell form itself through a relaxation process. Then to adopt a kind of so-called topology optimization, so a structural analysis finds out where the surface is working the hardest and increases the thickness and takes it away where it is working least. So in the end, you get a much more optimized, super light element, which is still strong enough. So this is the process of finding the reticulations. And then as a process of deciding, is again a choice how to translate these results into thickening and as well as perforating. And then you get something which is very organic, very beautiful, but super high performance. And then you can choose color to further express this. So there it becomes heightened into some kind of character, signature, form, and ornamentation, if you like. And a similar process we used for pavilion, etc., etc. So, and we're looking also at new fabrication technologies. They imprint their limitations, and they're super efficient, but they have their own kind of constraints, and then we work with them, and we love that there's a new kind of expressiveness coming out of that. Here it's not structural performance, here it's fabrication efficiency, which imprints itself. So we don't mind to have these layers of the printing process, this kind of factura giving character to the form. It's actually heightened this plasticity, it makes it more legible, etc. This is concrete printing. And again, this is very particular characteristic forms which come out of this. There's another version of a robotic printing onto a mold which we created, and you can vary the strengths and the porosity of such a shell. Or using hot wire cutting to make molds, which is 20 times faster than milling, but it imposes constraints. These are only ruled surfaces, but then all these elements which are created like this share a typical morphology, so they become recognizable subsystems. When it comes to towers, we also want to differentiate, not just have the same bottom, top, middle and top, and use the structure to give variation across the tower and character to the tower. And you can see here that all these towers are very different versions of one idea, which makes them then also a beautiful ensemble that could come together, because they all show how the structure is more triangulated at the bottom and stronger and becomes more calm and lighter to the top. So you can have unity across difference, both within the tower and across towers, which are developed from a similar methodology. And I think that gives unity and identity to an environment which is at the same time quite varied and rich. And this could at times become rather complex. Again, this kind of idea of a hollow out continuous variation tower. But here you would then see where the structure becomes thicker, you're at the bottom, where it becomes lighter, you're at the top, etc. Maybe the last one I want to show, one of the few last ones, is something which becomes a palace. So it compares back with kind of Gothic churches or Baroque palaces, and uses only high-performance morphologies like these shell forms, which are not spherical but parabuloid, and using various algorithms to optimize the ribs, and then making choices. I can make the ribs like this, like this, like this. So there's again artistic choice. All of them have degrees of optimality. You can bring in light, and you can then start differentiating different spaces. And instead of, like the different Gothic churches, now all in one project, the various atmospheres are differentiated. You know you're in the same building, but with very different parts of the building become now differently articulated. And this is the power we have for the tools, working with algorithms, working with 3D modeling, full simulation. It's the most design-intensive building we've ever made, you can imagine that. Instead of 300, 400, 500 years, with this kind of building took in the era of Gothic, we can do that in a few years now. And again, working with students. So this is what we're doing in the office, of course, comes on the top of a research process which took us quite a few years to develop and to optimize. And you can see here Google Campus proposals that I was teaching at Harvard, different shell formations. So we're trying to differentiate the campus so it's not all the same within each system. But then for such a large project, you nearly feel that all these different versions maybe should be part of one project, so you get more variety. But all of this is Tectonism, but in the end, I think they should be all more varied, and all of these should be becoming part of one project. So you get something, and I stop maybe here, wrap it up, because it's just collapsed again. I'm nearly at the end. You can see what the beauty and power of this way of working is. First, it is super light, super efficient, super light-footed environmentally and materially. But it is also, at the same time, gives us a wide range of articulating the new level of complexity and intricacy of the various spaces which come together in the big city, so that you can navigate and find each other, and we can overcome, I believe, in this kind of way of working, what we're finding now, that the various expressions of the city and of buildings are just chaotic in their juxtapositions, and we lack a convergence, stylistic convergence, because we're afraid of monotony. But here is a style and methodology, I think, onto which a whole discipline could converge, because there's so much internal variety and richness, nearly like the endless forms of nature, where we could have both sense of unity, navigability, and order, as well as that variety and differentiation we need. So it's a kind of complex, variegated order, juxtaposed to the over and unacceptable simplicity of the modernist city, which we have grown beyond, but also juxtaposed to what I believe is a menacing visual chaos we now encounter in cities around the world. So with this message, I want to invite you to understand more, learn more about parametrism, in particular Tectonism, and maybe join that effort, because it must be a collective effort. Thank you.